Hello, everyone, and welcome back. We're now in session 4, Seeing the World Through the Eyes of a Robot. I'm joined here by Moritz Vogt. He's an application engineer in product management for SICK. And we're also joined with a partner, NIA Advanced. So Jose Pedro Ferreira will be joining us from Portugal via live stream. I'm really excited as well to see what's possible now with time of flight, with the imagery that's available to work with depalletizing of robots, but also other applications. I'm not going to say too much. I'm going to let you take it away, Moritz. Go for it.
Cool. Yeah, so thank you very much for your introduction. And also welcome from my side. As mentioned, my name is Moritz Vogt. I'm an application engineer for the 3D snapshot devices of SICK. And yeah, I'm happy to be here and to have the opportunity to talk with you about our solutions for depalletization with our 3D snapshot devices, and especially about robot automated depalletization. Yeah, so let's jump straight into the topic. Depalletization of pallets is actually a key thing if you want to speed up and increase productivity and efficiency in your production and logistic processes. And actually, what we would like to have when we want to depalletize pallets are situations like you can see here on the image. These are perfectly stacked pallets on standardized pallets, so that means the boxes are always in the same position, have the same kind of pattern, and the robot actually just needs to pick from a predefined position. And also these boxes are often a little bit separated. However, what we really see in reality is something like this. So we have pallets that are randomly stacked, where we have boxes that have different dimensions, which are tightly stacked together, which are a little bit messy, and also pallets which are not standardized. They have different sizes, different dimensions. So that means the robot actually cannot pick here from a predefined position. The robot always needs to calculate the next box he can grip. And therefore, we actually need reliable and robust data to perform such kind of tasks. And these kind of random stacked pallets can come from either that the process is still manually done, so that means that a worker is putting together the pallets manually, or if the complete process is already a little bit more digitalized and the pallets come in more individualized on the customer's needs. So that means when we are talking about Industry 4.0 and lot size 1, these pallets are normally highly individual. So yeah, we need the reliable data to actually pick the right box and to ensure a good depalletization. And to do so, we will today have a closer look on how this can be done with our 3D snapshot devices. Our 3D snapshot devices are designed for any kind of industrial applications. And yeah, we are using for this 3 different technologies. So we are using the time-of-flight technology, the stereo technology, but also the combination of structured light and stereo technology to acquire 3D data. And snapshot in this case means that all of the devices do not need any kind of movement of the sensor itself or any kind of internal moving parts inside the sensor. So we really take the image with one shot, and this can happen at a high frame rate. And yeah, so you can see here the different product families. You can see in the background the Visionary S, the Visionary B, and Visionary T, which are using these kind of different technologies. And also the newest product family, which will join our product family soon, the Visionary T Mini, which is a compact but highly precise 3D time-of-flight camera. If you want to learn more about this device, I would also recommend you to join our session at 2:30, where we have a closer look on this device. But now coming back to depalletization and actually on the benefits we can use from the Visionary S product family. So yeah, so let's have a closer look on this. And therefore, I brought with me a short demonstration where we have the camera running live. And the Visionary S is actually a device which provides 3D data. So it's using active stereo technology, it's sending out structured light to acquire the 3D image. And on top of that, the camera also takes a 2D color image. And both these informations are already matched in the sensor itself. So that means the camera sends out 2D matched data with 3D information. And this is actually the perfect information, or actually the information we need to tackle the challenges I mentioned before. So we can now have the information about the height, the information about the position of the boxes, all coming from one device. Nevertheless, this is still only the raw data. That means the data itself still not gives you an idea of where the box can be picked. And therefore, we need some smart algorithms, some smart solutions to do so. And here we have partnered up with Neadvance, a company from Portugal, who is providing such a solution, and combined our camera with their software solution. And I had the opportunity to talk with Jose in advance about our solution, to give you some more insights, to talk a little bit about what we can do. And yeah, I'm happy to show you this interview, and I hope you can learn a little bit more about our solution. So see you soon. Hey, Jose.
Hi, Maurice.
Good to have you here. Thank you for joining us for this session. I just gave our visitors a short introduction of you, but maybe you can introduce yourself and also Neadvance.
Yes, so thanks for having me. My name is José Pedro Ferreira, and I work in Neadvance for about 15 years. I started as a developer in engineering, and after a while I became an account manager and also supporting sales. So Neadvance is a machine vision company, and it develops computer vision and artificial intelligence solutions for the market. We are based in Braga, in Portugal, and we are on the market for more than 20 years. So we have a broad and a solid know-how of the production process that we acquired in developing these and implementing these solutions, very complex automation systems. Today we have successfully installed hundreds of solutions in more than 16 countries and 4 continents, and we have big companies, big client companies like Bosch, PCA Group, Continental Tires, IKEA, just to name a few of them.
Cool, thank you. I also already mentioned that we decided to bring a solution together into the market. And actually, it would be nice to hear from your point of view, why have you as an integrator decided to work together with us and bring the solution to the market with SICK?
Yeah, so actually we have been using SICK cameras since the beginning. We always like very much their reliability and the robustness for the industrial solutions. And for the robotics and logistics solutions we have on the market, our first choice is always to use the Visionary T and S cameras. With the experience that we acquire in deploying these projects, we came to realize that the market asks may appear and sound different, but specialists for the pelletizing solutions, the core is actually the same. So to be constantly developing new solutions from scratch, it sounds inefficient and it makes no sense at all. So what we need to do is find a way to standardize such a solution. So SICK was the obvious partner with their hardware portfolio and your expertise combined with our software. We think it's a perfect match.
That's nice to hear. Yeah, so I think you and me already talked about it's a depalletizing solution we are offering. Could you give our visitors like a short introduction to it? What does it actually do, and what kind of task can we solve with it?
Yeah, so basically the palletizing solution has been designed to automate the production process and guide the robot to perform this operation. What the system does is that it generates the gripping coordinates and the rotation of the box position. We use a visionary camera to acquire the images and our algorithms to process the data, and all of this is done in the industrial computer that connects with the camera. And we ship all of this as a bundle for plug and play use in customer site.
And bundle in this case also means that it includes the camera and your control unit together with the software already pre-installed, like you mentioned,
Exactly.
really plug and play. Yeah. I guess a lot of our customers and visitors have already seen some kind of depalletizing solutions or maybe already used some. From your point of view, what makes our solution really unique and outstanding?
So it's a real plug and play solution. The customer just needs to plug everything, perform the two-step calibration, and it's ready to use. So with this, we are able to reduce the time to line drastically. We can have the systems fully installed really quickly on the customer side.
What does it mean? Are we talking here about weeks or days?
No, with our experience, we can have the solution in less than 1 or 2 days, fully installed. We have also the possibility to perform a quick pre-assessment of the data to check the feasibility, and with that we can also shorten the lead time. All you need is some pre-record data that it can be really easy done with the SIG software tool. And also the software is combining the RGB and the depth information to calculate the coordinates. So like this, we can achieve very accurate and repeatable results. By using this combined information, it allows us to detect very tight boxes regarding the other solutions, and we have also a very good response to the ambient light variations. The response time is also really fast. We can have the possibility to perform until 2,000 peaks per hour, and with an almost unlimited number of different box models on the solution.
You already mentioned that we have the possibility to make a really quick pre-assessment of data, and I think therefore we have prepared some demonstration videos and also material we can later on show our visitors. But there would be one last question before we come to that. You already mentioned that we are providing here a standardized solution, but how is it possible to have a standardized solution and at the same time we can still adapt to customer needs and to their requirements?
Yes, so the solution is highly flexible and modular, so it can be integrated into different packaging lines. It can be applied to pallets, to containers, to trays, to conveyors. We use OPC UA communication as an interface, so it can communicate with any PLC, with any robot. So we are agnostic to the brands. The camera can also be installed on the fixed position and also on the robot gripper. For this, the client just needs to perform the calibration with the targets that are also provided with the bundle. And the system has a lot of different smart features that can be really helpful, like single peak, double peak, the recognition of interlayers. We can also detect empty pallets. We can detect if there is any foreign or object to avoid any damage. And also the system monitors if the robot is picking the correct box. So these are some of the features we have available.
Okay, I think we are also able to see some of the features in our demonstration data. So yeah, let's see it in action, and maybe you can describe us a little bit what we see. So let's have a look on what we've done so far. Yeah. So as you already mentioned, we had the possibility to pre-record some data, and you use this data in your emulator demonstrator to make a quick pre-assessment, and maybe you can talk us a little bit through.
Yes, exactly. We received the pre-record data that you see on the top corner, on the top right corner, and we just loaded these images on our software that you see running on the video. And what the software is doing is that is detecting each one of the boxes. You can see the green square on the right image when it's detecting each one of the boxes, and you have the coordinates that the system is giving to the robot. So you have also on the box detected on the bottom that is letting the robot know which is detecting so far, and at the end you will know that the pallet is empty and give also that information to the robot.
Yeah, I think we can see it exactly now, the empty pallet detection. Yeah.
Basically.
I think we also recorded a second scenario where we had an unknown box on the pallet, and yeah, maybe you can give us an insight how we can handle such kind of situation.
Yes, on this particular case, the system is expecting to have boxes of one particular size. So if he finds any box or any kind of object that has different dimensions, he will know the system that is an unknown object, and to avoid having any damage on the gripper and so on. So this can be really useful for the client to have this information also.
Okay. Yeah, you can again see it down here in the bottom right corner. Yeah.
Exactly.
The next video then is actually a real video from one of our successful projects. And I think here we can also see some other features that the solutions brings with it. Yeah.
Exactly. Here we have the situation that the camera is mounted on the fixed position. You can see it there. And now the robot is performing double picks. Whenever it's possible to do it, the system gives that information to the robot. Is very useful to speed up the picking rate. And on this case, the system was not able to pick 2 boxes at a time, so is performing single picks. So this is one of the smart features mentioned that the system has available also.
Okay. Yeah, that sounds really, really interesting, and I guess it's also interesting for visitors. It's for us always a pleasure to work together with you, and I want to thank you for your time, for showing us all this interesting stuff, and hope to hear you quite soon.
Yes, you too. Thank you for having me. It was a
Bye-bye.
pleasure. Thank you.
Yeah, so I hope that gave you a good overview about our solution, some more insights, some more details. It's always good to hear from someone else who's working with it, who's working especially on the software side here. To sum it up quite quickly, what we provide with this complete solution, or with this package consisting out of the camera, the control unit and the software pre-installed, is a smart and efficient way to increase the productivity and efficiency in your production and logistic processes. Also, this is really a flexible solution, like mentioned before. So we can adapt to different kind of needs. We have like a state-of-the-art interface with OPC UA to communicate also with other kind of systems, with the cloud, which has already been realized in some of our projects. And at the same time, we also benefit from the sustainability and robustness of our solution. So we have a system here designed for 24/7 use in industrial environments, so also challenging environments. And all the data is generated within a single device, so all coming from one device, what makes it really easy to maintain. Yeah, and all this bundled up together, provided by us by SICK. So thank you for your interest.
Yeah. Thank you very much, Moritz. And also, Jose Pedro wasn't with us live, but I still want to thank him and NIA Advanced for giving this insight into the partnership. One of the things I was also interested in is the robustness. I know that if you take some shocks there if you're right on the arm, are there any moving parts in this in the Visionary? Is it something where there's mirrors and things like that?
So this is exactly what the 3D snapshot or where the 3D snapshots had its benefits. So that means we don't have any kind of internal moving parts, like no sensors, no mirrors or something, no turning parts inside. Everything is static and stable. So it is extremely shock and vibration robust.
Okay, yeah. He mentioned also the 2,000 pics per hour. It seems very fast. Is there a comparison to the previous version that was installed? Is there like a rule of thumb? How much faster was it?
It's hard to say, but actually, if the process was done manually, this is like a huge improvement.
Okay.
And also, if you compare it to some other solutions on the market, we can nearly double the pick rate of other solutions that are available. And due to the flexibility of mounting it statically on the over the robot cell or on the robot arm, we can also again speed up this process and really make use of this high pick rate, because the picking is only as fast as the robot is. So.
True. And if you get that high quality data, if you have the 3D information and you have better 2D information, I think he mentioned something like seeing boxes that are closer together, unusual boxes, this seems to allow then easier double picks as well.
Exactly. So sometimes it is hard, even with really reliable and precise 3D data, it is hard to actually distinguish between two boxes that are really tightly stacked together. And here, the combination of 2D and 3D images come into play. So we can see in the 2D image that these are two boxes, and if then the software still consider these two boxes as close enough together to be picked in a single pick, the software solution chooses for a double pick option and can then also speed up the process again.
Yeah. And I think what's also interesting on top of that is that if you just have a 3D camera, there's a lot of data going on there, right? There's just tons and tons of bytes. With these snapshots, you're not working with as much data as like trying to take into account an entire stream. So this must help as well with the speed of picking, right?
Yeah. So we are also in this case, we are flexible. So we can work with the entire stream of 3D data incoming in the controller, but also in order to make it more efficient or just on a triggered event, we can just send a trigger to the camera. The camera only takes a snapshot when it's needed. Right. So also the control unit and the software just needs to handle the one image. And also this one image contains the complete 3D information.
Yeah, very good. Thank you.
Yeah.
We have also a couple from the chat. It's good that I got my curiosity taken care of here, because now we've had the time to get a couple good questions. One is, apart from NIA Advanced, are you also working with other companies that use the data coming from the 3D cameras? And are there also collaborations with robot manufacturers?
So in general, we provide for our camera interfaces that are highly flexible, so common interfaces, and for that reason, we are also able to work together with all kind of robotics companies which want to integrate our cameras to their solutions. And also for other kind of integrators, they can use our streaming devices to integrate it to their solutions. So we are widely open for any kind of combination with our cameras.
Interfaces are then defined. We have the definitions of how you grab information from our cameras, and then the people can integrate them themselves.
Exactly.
And we can also help with this, obviously.
Exactly. And also we have the opportunity for our devices to be programmed by AppSpace. So that means we can program our devices, and like that also interested integrators can already integrate the data directly from the camera to the robotic system.
Mm-hmm. Oh, that's very good. They have another question that I like. Can we do something besides rectangles?
Yeah, sure. So that's a good question.
Or is it just limited to rectangles? You have to pay twice as much for circles?
Not at all. Okay. So rectangles are just like the things that are coming in mostly when you are talking about cardboard boxes in stacked on these kind of pallets. But we can also detect like circles and so on. So
he was asking specifically, made a little bit of a joke, but just to answer the question directly, also irregular shapes. So probably what he means is something that's maybe not as geometrically good looking.
Yeah. So with our devices, it's definitely possible. But as we are talking about a standardized solution here, we are talking here about predefined models, so that the software still needs to know what he needs to pick. It can be squares, it can be circles, whatever, but not like completely irregular shaped objects. This is then needs to be taught and be integrated in the software solution. But we would also have like some options to do this.
Very good.
Based on the data, it's possible.
Yeah, good. Well, speaking of shapes, we're in good shape for today. We've gone through 4 different examples. Today we talked about condition monitoring. We looked at ports and cranes, how this, for example, reduced the time of thousands of hours of servicing that would be needed. This is a direct way of saving money. We then went into what seemed to be a simple application of cylinder switches. We found out that this can be much more exciting than we ever imagined and also create great value. From there, the augmented reality example with scanners was fantastic. I'm really excited about that, as you know. And of course, Moritz here gave us some insight to the 3D snapshot with real value. Please stay with us. We have coming up in after lunch, which is at 12:30, we have an example of creating safe productivity with universal robots, an application there. We have another application with Magazino, so we're showing a couple partners in the afternoon. And another bonus is the artificial intelligence application with Vision, where Velux is going to be, I think you know them from doing shades, windows, and things like that for household use, for business use. We're really going to show some great benefits there, so stick with us, stick around, and keep on using the chat, keep on asking questions. I'm going to go and check to see if the cylinder switch applications were properly answered, because we're already passionate about our customers asking questions. And we'll look forward to seeing you back here in half an hour. Thank you, Moritz. Thank you to the audience.
Thank you.
Yeah.